My computer keeps beeping and stuff. Okay, here we go. Let's do this quick. Donnell.
Here.
Kayla. Kayla's absent. John Chavala.
Here.
Kayla's here.
Kayla's here. Awesome. Jasmine. Jasmine's absent. Matthew.
Here.
I'm here.
Who's here?
Jasmine.
Jasmine. Sorry. Okay. Matthew. Brandon.
Here.
Morella.
Here.
Maria. Morella. Maria. Jeshua.
Here.
Gracie.
Here.
Carlos.
Here.
Jose.
Here.
Ethan.
Here.
Natalia.
Here.
Jaylene.
Here.
Giovanna. Giovanna's absent. Taylor.
Here.
Jay. Jay. Gianna.
Here.
Jacob.
Here.
Roberto Valdez.
Here.
Reggie.
Here.
Ariana.
Here.
I have Giovanna absent. Is Giovanna here?
I'm here. It's just my microphone was being dumb. Sorry.
Stop being dumb, microphone. Dumb microphone. Okay. Okay, we got a lot to do, a lot to cover. So let's talk about what's going on with the new week. We have a new chapter. Hopefully you had access to it, but here we go. You have, well, let's take a look at the Canvas here. Oh, look at that homework you have to do. That was from before. Let's do student view. Let's see what your guys' looks like. Okay, let's look at the weekly agenda. Okay, so we're starting chapter 4, doing 4.2 today. Page 204, 3 through 65, every other odd, and there's a check your understanding. Okay, and then 4.3 tomorrow. We're doing rational exponents. We're doing exponents that are fractions, okay? And you have to remember all the new rules for exponents before we do the exponents as fractions. So I'm going to go over, do a quick exponential review. Now, there's actually a good video on this. Let's take a look at the modules. Like, I think, is this it? Oh, no, that's not a video. This one, the basics of laws of exponents. A good video shows the basics of the laws of exponents. Anyway, you can watch that. And let's see, is there anything else that, I think that's it. I think that's it. All right. So let's take a look at our assignment. Okay, assignment number 23. Go ahead and write this out. Lesson 4.2, page 204, 3 through 65, every other odd. And then put your name, the dates. Period 3, by the way, not period 2. Math 3 honors. I'm going to show you some basic laws of exponents that you got to know how to do, okay? So this can be Godzilla time, or you can write notes. It's up to you. A lot of you probably already know all this stuff. So here we go. Let me know if I'm going too fast, because I feel like I have a lot to do. I'm going to go very, very fast.
To write it down.
Yes, I can. Yes, I can. Sorry about that. There we go. Sorry about that. We're going way too fast. A little jumpy. Let me know when it's good. Okay, I'm going to assume that it's good. I'm going to get rid of this in 10 seconds unless someone speaks up. Okay, here we go. Now, multiple, okay. Okay, these are the laws. That's laws. Look at that W. Of exponents. Okay, so this is if the base is the same. Multiply. The base is the same. If I say x to the fifth times x to the third, do you know what that equals? X to the eighth. You add them. Okay? Any questions? I can explain why, but if you know that, I'm just going to move on. Divide is subtraction. If I say x to the fifth divided by x to the third, that is going to be x to the second. Okay? Now also divide. What if I said x to the third divided by x to the fifth? Really, that's saying x to the third minus 5 would be x to the negative 2. Okay, so that would be negative 2. Now, what is a... Let's pause. We'll think about, go back to this in just a second. We can also raise the exponents, exponent of an exponent, exponent. If I say x to the third raised to the second power, then you multiply those and it becomes x to the sixth. Okay? So those are multiply. You add, if the base is the same, you raise it, you multiply, subtract. Now, stop me if I'm going too fast. Let's go back to x to the negative 2. What that's going to equal is 1 over x to the positive 2. Okay? Anything negative, you write it as reciprocal. Same thing if I say 1 over x to the negative 3, well, that'll equal, like this is really x to the negative 2 is really x to the negative 2 over 1 and just flip it over, right? So this would be x to the positive 3. You just remember that there's like a little 1 underneath it. There's an imaginary 1. You're really doing the reciprocal, right? But it's really x to the 3. You wouldn't write x to the 3 over 1. You wouldn't write that. But it's really, you just do the reciprocal of it. So that's a negative exponent. Martians are coming. Okay. Negative exponent. Let's see. What if I said x to the negative 7 over x to the negative 2? Well, I could write that as this. X to the positive 2 over x to the 7. And then you can subtract that, and that would be actually x to the negative 5, right? 2 minus 7 is 5. Anyway, that's negative exponents, which equals, sometimes you have to write it as a positive, so this would really be 1 over x to the positive 5. Okay, either one of those. Sometimes they say don't write your answers in negative, so you have to change it to the positive. Okay. Another concept you got to understand is multiplying. Well, let's go like this.
Second row called?
This one is just, this is still negative exponents. I just drew a line there.
It's just another example.
You have negative exponents.
Okay.
Yeah. Sorry, I probably shouldn't have drawn that line there. I just did, and then I came up with the example. Here's an important concept. If I wanted to find the square root of 50, okay, this is simplifying. Simplifying exponents, run out of room. So right over here. So I'll get square root of 50. By the way, the square root is really, there's a 2 in front of there. We just don't see it. Why do we have a 2? I'm going to pause on this for a second here. We know that the square root of 25, I'm going to pause. I'm going to look at this. We know the square root of 25 is 5. That 2 isn't there, but I'm going to put the 2 there. Anyway, why? Because this says, can we find a number that can multiply by itself twice and get 25? Yes, 5 times 5. Now, a lot of times we do what we call the cubed root. Like the cubed root of 8 means, can I find a number that I could multiply by itself 3 times and get 8? That would be 2. Okay, so make sure you know that. And another way I could write this cubed root of 8 is the same as saying 8 to the 1/3 power. That's the same exact thing. 8 to the 1/3 power is also 2 because it's the cubed root of 8. It's the same thing. And if I do the square root of 25, it's the same as saying 25 to the 1/2 power, right? Because remember, there's an invisible 2 there. It's the same thing, right? So this denominator really is the root, right? What are we rooting it by, right? So if I said the 4th root of 81 means, hey, that means I could write it as 81 to the 1/4 power. Or what can I multiply by itself 4 times to get 81? 3. Okay? So hopefully you understand the fraction. Now, going back to the square root of 50. The answer to this would be 5 square root 2. Sorry. Square root of 50 is equal to 5 times the square root of 2. You've probably already seen that, but here's how you figure that out. You kind of go like this. You take the 50 and you find its prime factors, right? 50, what's 50 divisible by? You pick anything that's divisible by. Like it's divisible by 5. 5 times what? 10. Now you're looking for its prime factors. The prime factors is when it is not divisible anymore. Like I can't divide 5 by anything else. It's prime. But I can divide 10. 10 is 5 and 2. Because 5 times 2 is 10. That's prime and that's prime. I can't make it any smaller. So square root of 50 is 2 times 5 times 5. Now remember, this is the square root. So I need to find 2 of them. So what this means is I can get the square. I see the pair here because 5 times 5 is 25. But any pair that you see, square root of 25 is 5. You can take that out. And our answer is 5 square root 2. I don't need this. 5 root 2, which is that. And that's how you come up with that. The last thing, couple more things I want to show you, okay, is fractions in exponents. Fractions and exponents. I can say 8 to the 2/3 power. Okay, now how would we write that? Well, remember, this is the cube, and this would be our exponent. I can write this in 2 ways. Because remember, this is good. You usually think the denominator is like makes it smaller because you're dividing. So I can write this like this. The 3 goes there because that's going to make it smaller. And then the 2 is going to go on the outside. That would be that. Okay? Or it doesn't matter what order I can also write it like this. Either one will give me the right answer, right? I can either square it. What's this thing? This thing I square the 8 first, and then I get the cubed root. This thing I get the cubed root, and then I square it. Let's do this one first. What's the cubed root of 8? What can I multiply by itself 3 times to get 8? 2. 2 times 2 times 2 is 8. And then I say, well, that's 2, and then 2 squared is 4. Here, We can square 8, which is 64. And the cube root of 64 is also 4, right? So anyway, that's the fractional exponent. Now, one more thing I need to show you, then we'll do the homework, okay? Let's say I say 2 times square root of 5. What would that equal? 2 times square root of 5. Am I teaching to error? Okay. Let's go with, let's see, try to pick someone at random. I know you guys can see. Okay, Brandon, what would you say 2 times the square root of 2 times square root of 5? What would you say that is?
I don't know yet.
Take a guess, random guess. What does it look? It's easier than what you think. Don't think too hard. Brandon?
Yeah.
What do you think? Something easy. It's right there. It's right there in front of you. Square root of 2 times the square root of 5. What do you think, Brandon? Just give it a guess.
Can you simplify that further or no?
You're trying too hard. Don't even think simplification. Just do it, man.
I'm not sure.
Come on, Brandon. Give me something. Give me a number. Give me a number. Any number. What number makes sense?
10?
Yes. Thank you, Brandon. Square root of 2 times square root of 5 is square root of 10. You can just go ahead and multiply those out. And that's all you got to do. Is that what you meant by simplifying, Brandon?
No, but
Okay, but that's all you have to do. As long as these are the same, you can just multiply it. Now, I can also say this. Oops. 2 to the 1/2 times 5 to the 1/2. This is the same. Since the exponent's the same, since the exponent's the same, I can just write that as 10 to the 1/2. I can even say 3 to the 2/3 times 7 to the 2/3. What do you think that's going to equal? Giovanna, what do you think 3 to the 2/3 times 7 to the 2/3 is going to be, Giovanna?
Sorry. Because I know you have to multiply them, so that's 21, and then I don't know how.
21 to the 2/3. That's all you do. Just keep the 2/3 the same.
Okay.
Right? Just like this. 2 to the 1/2 times 5 to the 1/2 is 10 to the 1/2, right? Square root of 2 times square root of 5 is square root of 10. I can even go cubed root of 7 times the cubed root of 5, right? That's going to equal, what's that going to do? Cubed root of 7 times cubed root of 5. Kayla, what do you think that's going to equal? Cubed root of 7 times the cubed root of 5.
35 square root?
Cube root, yeah. Cube root. But you're right. I know what you mean. Yeah, 100% correct. I know what you mean. Okay, let's start looking at our homework now. Okay? So those are the basics. There's also, actually, no, I have one more I want to show you. One more I want to show you. Actually, you know what? I'll show you with the homework. Okay? Let's get to the homework. Let's nail this thing out. Okay, so the assignment, remember you have a self-practice. Remember you have a check your understanding. Oh, that's not supposed to be showing up, the self-practice upload. I did not want to do that. Let me get rid of that thing. You guys still there? Let's see. What just happened? Oh man, it's hot in there. Okay, so let's take a look at the self-practice here. Okay. Let's do number 3. Okay, here we go. Sorry, I'm bringing up the... Okay. Okay, number 3. Wait a minute. What is this? This is not the one. Hang on, this is the wrong one. Oh, that's 4.3. Come on, foo. Come on, foo. Four 4.2. I don't want to do that. What's going on? Okay, self-practice. Here we go. Sorry, guys. All right, self-practice. Clickety-click. I had that screen open, but it closed. All righty, number 3. Okay, 9 to the second raised to the 1/3 power. Number 3. 9 to the second raised to the 1/3 power. What does that equal? All right. Go ahead and give that a second to go ahead and solve that. 9 to the second raised to the 1/3 power. Okay, let's go with... Okay, what's the first thing that we're going to do with this, Jose? What's the first thing you want to do here? What is the first thing you did?
I'm not sure.
Really? I went over a bunch of laws. Think of a law that you could use. There's no wrong. There's more than one way to skin a cat on this one. So,
Well, I guess fraction exponents makes the most sense.
you could do that. So what would that be?
It would turn into, I guess, a square? Correct? I'm unsure.
Let me ask you, Jose, let me ask you something real quick. If I said x to the second raised to the third, I did that as an example, what would that equal?
X to the second raised to the third. I'm not sure. You should probably call on somebody else.
Ah, were you sleeping?
I mean, I'm kind of tired right now, but I'm still taking notes.
Oh my goodness. You're still what?
Taking notes.
Taking naps?
No.
Take naps after class, Jose. Naps after class. Jasmine, what is x to the second raised to the third?
X to the
What? You cut out. Jasmine? Did I freeze? Am I gone?
No.
Oh, Jasmine. We lose Jasmine? Okay, fine. Very convenient. Okay, Roberto, what's x to the second raised to x? Come on, somebody tell me. I'm like gonna poke my eyeballs out if you can't know this.
X to the
X to the
sixth?
second raised.
81 to
What?
81 cube root.
No,
The answer.
okay, that's right for number 3. I'm asking what's x to the second raised to the third.
X to the
What's
6th.
X to the 6.
Thank you so much. Oh my goodness. So yes, you multiply it. Now you could write this as you multiply 1/3 times 2 is 2/3. Now that doesn't really simplify it, but I just want to make sure you understand that. So yes, this is right. Who said that? It was, I can't remember who said this was
I think it was
81.
Kayla.
Kayla, very good. 9 to the second is 81. She's right. But now I get the cube root of 81. Okay? So I need to find 3 things, something I multiply by itself 3 times and get 81. Now it's not 3, but we can take 81, remember we can take the prime factors. 81 is 9 and 9, right? That's not prime. 9 is 3 and 3. Prime. This 9 is 3 and 3. Prime. So 81 is 3 times 3 times 3 times 3. Now, how many do I need to get out of here? I need 3. Look at this. There's 3 right there. Cross them out. And that gives us 1, 3 on that because that's 27. So my answer is 3 cubed root 3. Because I still have this 3 left in there. And that's all you have to do for number 3, even though that is a lot. I'm going to move on. Doing number 7. Ready? This is all, a lot of this is review. That's why I'm going kind of fast. A lot of stuff in one little thing there. Okay. Can I move on, or do you guys want to look at that a little bit more? I'm going to move on in 10. 5, 4, 3, 2, 1. Okay. 7. Look at 7. Look at all this. They're just doing all the exponential rules. 8 to the 4th divided by 10 to the 4th, all raised to the negative 1/4 power. Okay, power. So I basically multiply this times this and this times this. Another way I can write this is 8 to the 4th raised to negative 1/4, all over 10 to the 4th raised to the negative 1/4. See that? Since they're all, I just separate it. And I can just multiply. Negative 1/4 times 4 is 8 to the negative 1. Negative 1/4 times 4 is 10 to the negative 1. Any questions on how I got that? 1/4 times 4. I can multiply it here if you don't know. Negative 1/4 times 4, right? These cancel out, and you have negative 1 left over. Now I have the negative exponent, so this means I can make this a positive on the bottom, this a positive on the top. It becomes 10 to the 1 over 8 to the 1. Both divisible by 2. 5/4. 5/4. That's number 7. Fun with exponents. Can I move on? Let's move on. I'm going to get rid of this in 10 seconds unless someone says stop. 9. 2, 1. Okay, let's go with number 9, 11. Let's look at number 11. Number 11. Should I let you guys do that on your own? Oh, yes. Number 11. Remember what I said. 2 2/3 times 16 2/3 all over 4 2/3. I'll give you a second to write that down. This one is not that difficult. No, maybe it is. Remember what I said? If as long as the exponent's the same, you can go ahead and multiply those mother fathers. Like what's 2 times 16? 32 to the 2/3 divided by 4 to the 2/3. What's 32 divided by 4? 8 to the 2/3. Now I can take that 8 to the 2/3 and I can simplify it even more. Remember 8 to the 2/3, what does that equal? 8 to the 2/3. What does 8 to the 2/3 equal? Let's go with Jacob. What does 8 to the 2/3 equal?
8 2/3 with that. I'm
Oh, you're
confused.
simplifying.
What?
No, what's another way? What's another way I can write that?
8. Like, what do you mean by another way you can write it? Sorry for my dogs.
Well, I don't mind your dogs. They're cool. What is the? Don't mind my tape on my finger. What is the exponent?
Two-thirds. 8.
No, Jacob. No, your dogs are fine.
Oh,
Listen,
sorry.
don't worry about them. Don't worry about them. Let them bark. I like it. One of these is the exponent, and one of these is the root. You have 50-50 chance. Is the 2 the exponent or the 3 the exponent?
The 2.
Great. So that means this is the root, right?
Yes.
Okay. Now, thank you, Jacob. Now, can we simplify that? Just say, what's 8 squared? 64. And then the cubed root of 64. What can we multiply by itself 3 times to get 64? I don't think there's anything. So you do the breakdown. Break it down. Oh, do 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 do. Oh, stop. Hammer time. Every time you see me, the hammer is so hyped. It's hammer this, hammer ho, hammer hem. And the rest is on the mic. Can't touch this. Do do. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. What do I need? I'm looking for sets of 3. Here's a set of 3. Boom. Here's a set of 3. Boom. 2 times 2 is 4. That makes sense because 4 times 4 times 4 is 64, and your answer is 4. It's 4. Moving on. Oh, 13, 15. Okay, you guys should be able to do 15. I'm going to ask you what the answer is to 15. I'm going to give you guys 30 seconds to do 15. 30 seconds. I'm looking at it right now. You should have the answer in your head right now. I'm writing it down. Okay, what's the answer? Here we go. Oh, fourth root. Let's see. The fourth root of 6 times the fourth root of 8. Let's go with. Ariana, what do you got?
I got 4 with the root with 48.
Fourth root of 48. Very good. That was strong. Thank you. Fourth root of 48. Now, does that break down anymore? Break it down. 48 is 6 and 8 and 2 and 3 prime. 8 is 2 and 4 prime. 4 is 2 and 2. Let me know if this is confusing to you what I'm doing. Trying to find sets of 4. 2 times 2 times 2. 1, 2, 3. There's 4 2s times 2 times 3. Look, I need 4. There's a set of 4 right there. Boom, 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 boom. So that means hasta la vista, baby. 2, fourth root, 3. There, that's your answer. Moving on. Am I going too fast? Can I move on? Oh, Stop. Hammer time. Stop. Hammer time. Stop. Hammer time. Proper. Okay, sounds like you guys are good. Okay, that is 15. Let's go with 19 next. Oops, there's my calendar. That's not what I want. 19. So just multiply and simplify those, okay? Multiply. I'm gonna skip 19. You guys do that on your own. If you want me to do it after class, you can. Let's do 23. 23 is new. New set of problems. 23. Cubed root of 5 over the cubed root of 4. Wait, this one. Not sure. Can't simplify that anymore. Oh, no, I know. Okay. Okay, remember what I said, what the problem is with this? You cannot have a root in the denominator. So I have to get rid of that root. I can't have this root here in the denominator. I can't. So I need to make this a number that I can find the cubed root of, right? Like, what are my perfect cubes? I got 8, 27, 4 times 4 times 4, 64, I think, is one. So I can make this into a perfect cube through multiplication by making it an 8. I can make this 4 an 8 because it's a perfect cube. So what do? What do I multiply 4 by to make it a perfect, an 8? What do I multiply it by? Yes, 2. But I got to also multiply the numerator by 2 also. Sorry, I don't know why I did that. You only need one of those. And so cube root 5 times cube root 2 is equal to the cube root of 10. Cube root of 4 times the cube root of 2 is the cube root of 8. And we all know that the cube root of 8 is 2. And there's your answer. That's how you do that. Oh. Any questions? Is anyone paying attention? Are you guys learning anything here? Wondering if you guys are even learning anything.
Yeah, we're learning.
Yeah.
All right, I got it. Thank you. 27. Okay. 27, straightforward. Nah, not really. Maybe not. 64, 49. I want a perfect cube root in the denominator. So the way I write this, I can rewrite this as cube root of 64 separated over cube root of 49. Okay, to make this a perfect cube, 49 is 7 times 7. So a perfect cube would be 7 times 7 times 7, which is 49 times 7. 49 times, I don't know what that is. I have to 3, 6, 28, 343. Cube root of 340. So what did I do there? Sorry. I multiplied by the cube root of 7 to make it a perfect cube, because 7 times 7 times 7 is 343. But I also have to multiply this by the cube root of 7. So now 64 times 7. 448. So the cube root of 343 is going to be 7, because 7 times 7 times 7 is 343. So this will be 7 over the cube root of 448. And that's your answer for 27. But the main thing is you have to get rid of that. You got to get rid of that radical in the denominator. You cannot have that. All right. That's 27. Do you guys, I'll keep it there. I'm going to get rid of it in 10 seconds unless you need it.
Can you show the whole page?
I will try.
Not the whole page, but like that whole question. There you go, right there.
Okay, I'm moving on. Okay, that was 27. 29, we're on 31 now. Halfway done. I'm like doing all your homework. Okay, okay. This is different. Now remember, you cannot have a radical in the denominator. Radical is another word for root. But anytime you add a radical like that, like I have this here, you have to multiply it by its conjugate. And if you multiply with the conjugate, some awesome things are going to happen. But I know what you're saying to yourself. Sensei, what the heck is a conjugate? Well, a conjugate of 3 minus the square root of 2. Does anyone know what the conjugate of 3 times the square root of 3 minus the square root of 2 is? Does anyone know what the conjugate is?
What is a conjugate?
That's what I'm asking you. If anyone knows it. I'm gonna show you what it is in a second if you don't know it. Okay. Anyone before I show you? See if you see what the pattern is. The conjugate of conjugate of 3 minus square root of 2 is 3 plus the square root of 2. That is the conjugate. Okay? So the first number stays the same. The second number is going to be the opposite. Okay? Now, whatever you multiply the denominator by, you have to multiply the numerator by. So this also has to be multiplied by 3 plus the square root of 2. Now, something awesome is going to happen here. Let's multiply 3 minus square root of 2 times 3 plus the square root of 2. It's not that hard, especially if you do a graphic organizer. I like the graphic organizer. Oh, but Sensei, it's math 3. I don't know. I think it's easier. So here we go. 3 minus the square root of 2 times 3 plus the square root of 2. Okay, so let's see what happens here. First box, what's 3 times 3? 9. No problemo, that was easy. Okay, second box, what's 3 times negative square root of 2? Well, that's going to be negative 3 square root of 2. I'm sorry, yeah. Any questions there? Now, what's 3 times the square root of 2? It's 3 times the square root of 2. Do you guys notice anything about those two numbers? If this is positive and this is negative, 3 times square root of 2 minus 3 times square root of 2 is going to go away. Now, square root of 2 times negative square root of 2. Let's do this over here. Negative square root of 2 times the square root of 2. Well, I can multiply these because they're both square roots. Square root of 2 times square root of 2 is going to be the square root of 4, and then this becomes the negative, right? What is the square root of 4? 2, and that's negative 2. Notice the square root disappears. So this is negative 2. So my final answer is now 9 minus 2, which is 7. That's my denominator. And my numerator is going to be 5 times 3 is 15. And 5 times square root of 2 is 5 square root of 2. And that is your final answer. I'll let you look at that for a second so you can contemplate it. Okay. I'm going to get rid of this in 10 seconds unless someone still needs it. And 35 next. 5, 4, 3, 2, 1. Okay. 35. Now look at 35. You also have to do the conjugate because you have that addition. 6 over square root of 3 minus square root of 5. Okay. Now, what do you think the conjugate, see if you can figure this out, of square root of 3 minus square root of 5 is going to be? It's the same exact pattern as the one we did here. 3 minus square root of 2, conjugate is 3 plus the square root of 2. What do you think it's going to be for square root of 3 minus square root of 5? Okay, let's go with Carlos. What do you got? What do you think it is, Carlos?
Square root of 7?
Oh, wait.
Oh, no. Square root of 8?
Okay, wait. You're adding them. Oh. That's actually interesting that you said that, because you could just subtract them. Wait, could you subtract them? No, you can't subtract them. Good thinking, Carlos. You can't subtract them. You can only multiply them. You threw me off there.
Oh, square root of 15?
No. Carlos, look here.
Yeah.
See how the conjugate, just real quick, I know. See how the conjugate is 3 minus square root of 2? The conjugate is 3 plus the square root of 2. See this pattern here?
Yeah.
Can you apply that pattern for this?
Square root of 3 plus square root of
plus square root of what?
5.
Perfect. That's it. That's the conjugate. You guys see that? Very good, Carlos. Thank you so much. So then this is going to be...
I have a question.
Yeah, what's up?
Why'd you put 2?
I don't know, because I'm dumb. Should be a 3. Oh, and I got to rewrite the whole thing. Thanks for... I don't know why I did that. Square root of 3 plus square root of 5. Square root of 3 plus square root of 5. Okay, so now I have to multiply these. So why don't you guys go ahead and multiply those, and I'm going to call a couple of you at random, see if you can get the answer. So we're going to say square root of 3 minus square root of 5, square root of 3 plus square root of 5. Right? By the way, let's do the first box together. Square root of 3 times square root of 3. Square root of 3 times the square root of 3. What is square root of 3 times square root of 3? Just multiplying. Square root of 9. What is the square root of 9? 3. So that's your first box. And by the way, you can just get rid of the square root if you see the pattern. Okay, so go ahead and fill out the rest of the boxes. I'm going to ask you what's in the boxes. That's what I'll do. What goes in my boxes? Okay, so there's 3 of you I'm going to call on at least. Okay, I want the simplified answer. Like this isn't square root of 9, it's 3. I want the simplified answer. Okay, another 10 seconds. Get ready. I'm going to call on you. I'm calling you. I'm pushing you. You got to dig deeper. You got to dig deep, guys. Dig deep. Okay, time's up. This box right here. I want this box right here. This box. What do you get in that box right there? Get ready. I'm calling on you. This box right here. Here we go. Let's go with Jose, give it. I'll give you again, Jose. What do you think goes in there, Jose?
Negative square root 15 or negative
Thank you
3.8.
so. Whoa, man, you're going fancy. Just the negative square root 15 is fine. Perfect. Okay, Matthew, what goes in this box right here, Matthew?
Is it square root 15?
Perfect. Okay, now look. Square root of 15 minus square root of 15. What happens to those square root 15s there, Taylor? What happens to this square root of 15 and negative square root of 15, Taylor?
They cancel out.
They go away. Boom, boom. Gone. Now, what goes in this box here? Okay, what goes in that box there? Let's go with Reggie. What do you get? Reggie, what goes in here, in this box here?
Negative square root of 25.
Yeah, can you simplify that even more? Because Reggie's 100% right. Square root of 5 times negative square root of 5 is negative square root of 25. Can you simplify that more, Reggie?
Would it be negative 5?
Negative 5. Okay, you guys see that? Now, 3 minus 5. What's my final answer? Natalia, 3 minus 5, what'd you get?
-2.
Negative 2. So my denominator after all that is just negative 2. Now, square root of 6 times square root of 3. What do we get there? Let's go with Giovanna. What goes here? Square root of 6 times square root of 3?
Do you multiply them or do you add them?
Oh, yeah.
Which one?
Look it. See what I'm pointing here?
Yeah. Yeah. I was asking if you multiply them or you add them.
What is this?
Oh, you multiply. Yeah. Hold up. It's 18.
Don't forget the square root of 18. Very good. Plus square root of 18 plus what? Jeshua, square root of 18 plus what?
Plus square root of 3 plus square root of 5.
Square root of 30.
There.
3, 10. No, it doesn't simplify anymore. I'm assuming you thought it was square root of 30. You try to simplify it. I don't think it simplifies anymore. So it's square root of 30. I don't know. Is that I don't know if that makes sense to you, Joshua. Does that make sense?
No, please elaborate.
What's 6 times 5?
Oh, 30.
Yeah.
All right.
Yeah. Okay. Because this sounds okay. 35. What are we on now? 37. Okay, so I think I'm just going to show you one more. I think I'll be done. You guys surviving okay? I know this is a long day.
Pretty good.
Just
Pretty
a lot.
good.
Oh, thank you. I don't know. I mean, I know it's just so much information. I don't know how else to show it to you guys. I really don't. I think the best way is just to show them to you. Okay, number 39. Okay. I don't think I've shown. Have I done it? Okay, I haven't done this with you guys. This is very easy. I think. Maybe I'm wrong. But let me ask you something. This is 11 and 1/4, and this is 11 and 1/4. They're both the same. Let's pretend like I have 3 and 11 and 1/4, and I'm adding to that 9 11 1/4. I have 3 11 1/4. I'm adding 9 11 1/4 to these 3 11 1/4. Another way to look at it, don't write this down. This is like Godzilla time. Let's say I have 3 apples, and I add another 9 apples. I have 3 apples, and I have 9 apples. What do I got left? Let's say, I don't know. Marilla, I have 3 apples and 9 apples. What do I got?
12 apples.
12 apples. Marilla, stay there. I have 3 11 and 1/4, and I have 9 and 11. Instead of apples, I have 11 and 1/4. That sounds weird, but hopefully that makes sense. I have 3 and 11 and 1/4, and I have 9 11 and 1/4. How many 11 and 1/4 do I have?
It's going to be 11 and 11 1/4.
You mean 11?
12 times 11 1/4, sorry.
Very good. Thank you so much. That's 100% correct. Now I have 12 11 1/4. That's the same idea, right? It's kind of like terms, except my term is left. That's it. That's all you have to do for that. Okay. 39, 41, 43. Oh, look at 43. This will be my last one, I think. 43. And then maybe we'll look at 47. Let's see. Do I need 43? Okay, now look. You can only add them up. Well, let me write it down so you can see. 5, 2, 2, 4 plus 3, 5, 7. Now remember, in addition, you can only add them up if they're the same. However, these are different. Son of a mother, right? These are the same. 11 1/4, 11 1/4. If this is 5 root 7, then I can add them, but it's 5th root of 224. Now, let's see if we can solve the 5th root of 224. So let's do our little factor tree. 224. Okay, 224. What goes in 224? Let's go with, I don't know, 2 does. 4 probably does. Maybe 8 goes into 2. Let's try 8. Does 8 go into 224? 22, 4. Let's go with 2, 16, 64, 28. So 8 times 28 equals 224. Okay, now I want to find my prime factors. 8 is 2 and 4. There's prime. 4 is 2 and 2. Prime, prime. 28 is 4 and 7. 4 is 2 and 2, and 7 is prime. So 224, this is the 5th root of 224. 224 is, 5th root of 224 is 2 times 2 times 2 times 2 times 2. 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, that looks really good. Plus 3 5th root 7. So I brought my 224 down here, right? So I need 5 of these. 1, 2, 3, 4, 5. Look at that. These go out because I need 5. That means my 2 goes here. And what do I have left over in there? Is that 7 plus 3 5th root 7. Now I can, sorry, in the way. Now I have 2 5th root 7s plus 3 5th root 7s, right? Remember my apples? I have 2 apples plus 3 apples. But instead of apples, I have 5th root 7s. 5th root 7s. How many 5th root 7s do we have? We have 5 5th root 7s. That's a weird 7. There you go. That was 43. You guys want to look at that for a second? Basically, what you want to do, like if you want to look for a common radical, if the radical is the same, you can go ahead and add them up. But this wasn't the same, but I kind of figured, you know what? I bet you could break it down and make it down the 5th root 7, and it's 2 5th root 7s. I have 2 of them. And then that's that. So that's 43. Let's look at 47. What's the error here? 3 12 cubed root 12 plus 5 cubed root 12. Look what they did. Looks good. 3 plus 5 is 8. The mistake is right here. You don't add the 12s. It's not 8 cubed root 24s. There's 8 cubed root 12s. I have 3 cubed root 12s here and 5 cubed root 12s here. So it should be 8. You don't add those up. That's the mistake. And then, I don't know. Maybe you can figure these out, 51. I pretty much did most of your homework for you. Such a bad teacher. So I think that's it. Are there any questions? You guys did great. I'm sorry. Anyone fall asleep? It's okay if you did. I'm looking at you, see if anyone fell asleep. All right. You guys, you can go if you'd like. If you have questions, you may say after class. I'll see you guys tomorrow. Don't forget your check your understanding. Bye, Kayla. Bye, Gianna. Bye, Jeshua. Bye, Gracie. Bye, Taylor. Bye, Jay. Bye, Jasmine. Bye, Brandon. Bye, Roberto. Bye, Natalia. Bye, Ariana. Bye, Marilla. Bye, Ethan. Jacob. Jasmine. Bye, John. Bye, Carlos. All right, you guys have questions?
Yeah. So I'm not gonna be here on Thursday because I'm getting surgery for my wisdom teeth.
Ooh, I gotta do that with my son. Who's your doctor?
Um, I
Do you
don't I
know?
don't remember his name.
I gotta figure out who to get. I'm sorry,
So
Reggie. I wasn't. So yeah.
do I
Okay.
just
So Thursday. Um. Well,
do
I'll
I
have
just
the video. You can watch that on Friday,
okay?
and you can see if you can do it ahead of time.
All right, I'll
I
try to
have
do
it,
that.
and then Friday I have a quiz.
Okay.
You'll be. I won't mark you if it's late. Don't worry about it. But watch the video if you need help. Thanks
Okay.
for letting me know.
Thank you.
Good
Bye.
luck with that, man. With the wisdom teeth.
That's gonna suck.
Are they gonna knock you out?
Yeah.
Well,
Then I'm
that'll
not.
be kind of fun.
Yeah, but I'll have blizzards all week.
I know, but you're getting it done. I got to make that appointment for my son.
All right.
Anyway, thanks for reminding me. Good luck on that, man.
Okay. Have a great rest of your day.
All right, you too, man. Okay, next question.
For me, I just wanted to inform you before I go that I tested positive for COVID, which sucks.
Oh shoot, how you
Yeah,
feeling?
just pretty fatigued lately and headaches.
Okay, okay, that sucks, man.
Mm-hmm.
So you have to stay home for 2 weeks?
Well, I've been staying home because quarantine. But yeah, I
Yeah.
think I
Anyway.
caught it from my mom because now my little brother and me have it.
Oh shoot. Okay. All right. You did too, Giovanna? Right now? You have it?
No, I had it in the beginning, but like I
Okay.
got
Oh,
yeah, I got like
Matthew, you got it. Well, you guys are my COVID patients. Okay, well, or my COVID students. Well, listen, Jose. Hey, listen, just do okay. Okay, cool. Thanks for letting me know. If you cannot do anything, let me know and I'll do makeups or whatever for you. Like you can retake quizzes or anything like that. Okay? I won't say I shouldn't say this, but you'll be in my prayers. Okay? Hope you get better. All right. All right. See you later, Jose. All right. Who's next? Let's do ladies first. Giovanna, go ahead.
Oh, okay.
Unless you want to talk privately or something.
Oh, that's fine. I
Okay.
don't know how to find the perfect square because I think you're
What's
doing it
that?
to find the perfect square.
Okay.
You're either doing it on 27 or 23, and I didn't really understand.
Okay. Let's see. Fine. Oh, okay. I know which one I know what you mean. Okay. That'll take a little, let's see. Let me see if, Matthew, do you have a quick question before I go over Giovanna's?
No, not really. I just wanted to go over it. Yeah, I kind of had the same question though.
Oh, perfect. That works great. Okay. No, that's a weird one. Okay. How do I describe this? Shoot. It's kind of like takes a lot of intuition. This one's easy but hard to understand, I think. It was 23. I think once you get it, it's easy, but it's hard to like grasp it. Okay. Let's do 23 first, right? This one right here, right, Giovanna?
Yeah.
Okay. So, first of all, this is how I'm, see if I can describe it. So, you know, the 3 means I need to find something that I can multiply by itself 3 times to equal 4, right? The way it stands right now. But there's nothing. I know 2 times 2 equals 4, so I can find a square root, but not a cubed root. But usually all my cubed roots are something like if I was to write it here on this paper here, like a cube root is like 2 times 2 times 2, 8, right?
Wait, so
8's a perfect cubed because that
are
equals 2.
you presenting?
What's that? Oh, I'm not.
Yeah,
Sorry.
it's okay.
Okay. It would help if I was presenting. I assume it's on. I'll start over. Okay. Here we go. So, okay, what this says here is this is the cubed root, right? I want to find something I can multiply 3 times and get 4. But there's nothing, no whole numbers that can't, right? I know 2 times 2 is 4, but I need 3 of them. Now, what I was saying before, and same thing with 3, but the problem is I can't have this in the denominator. I got to get rid of the root. I got to get rid of this thing, okay? You can never have it in the denominator. Now let's talk about what a cubed root is. Anything that I can multiply by itself 3 times will be a cubed root. Like 2 times 2 times 2 is 8, right? And the cubed root of 8 is 2. Now, if I did 3 times 3 times 3, 3 times 3 is 9, times 3 is 27. That's a perfect cube also. Why? Because the cube root of 27 is 3. But I found it out by just multiplying it by 3 times with each other, right? Now, this right here, I know 4 is not a cube root, but I know 8 is. So if I change this 4 to an 8, what do I have to multiply it by?
Is it by 2?
Yes. And whatever I do the denominator by, I have to multiply the numerator by. So what does that become? Well, 4 times 2 is 8, cube root of 8. I just want to find that magic number. My magic number is 8 there. Find the cubed root. And then this would be 5 times 2 is 10. And the cubed root of 8 is 2.
Could you have used a different number, or did you have to use 8?
Well, I don't think I could do another number, but 8 would be the easiest. So what I could do is 4 times 4 times 4, which would be 64, I believe. I could use 64, or I could use, you just want to, you can, whatever you want to make this, whatever, you can change this to any cubed root that you want. I just figured 8 is the easiest. Any perfect cube, any perfect cube. And the way you find perfect cube, like, is you just multiply a number by itself 3 times. So yes, 4 times 4 times 4 would be 64. So you'd have to multiply it by 16 to get 64. And then you have to multiply this by 16. Do you want me to do that so you could see? You'd have to simplify it again, though.
Yeah, can I see it? Please.
Okay, so let's say, now that just makes it a,
or you can like do like a different problem if it's too much, and then
I don't mind doing this one. I could do whatever helps you understand this. But, well, let's do a different one. Let's do a different one. Maybe that'll, so you can see. Let's, let me make one up. Let's do cube root of 3 divided by the cubed root of 5. Whoops. Cube root of 3 divided by the cube root of 5. So now I need to find a perfect cube that I can multiply this. Well, Matthew, right? Is it Matthew? Matthew, can you think of a number that would be a perfect cube, or are you? I just want to see where you're at with this.
10.
Well, 10's not a perfect cube.
Oh, wait, 15?
You're doing 3 times 5. You want to do 5? I understand you're like right there. You're like real close. Well, the perfect cube is a number. Remember, a number you can multiply by itself 3 times. I have 5. So it would. What I would think. This is 5. 5 times 5 times 5. 5 times 5 is 25. Why did I do that? Because I have 5 here. I want a perfect cube. Well, there's 1 5. Is that a perfect cube? 5 times 5?
No.
No. So what do I have to multiply by again?
5. Or square root of 5.
There's your 3 cubes. 5 times 5 times 5 is 125, which is, I have this one here, and this would be there. I just have to multiply 2 other 5s to make it a perfect cube. And so, sorry, I need the 3 there. So 5 times 25 is 125. And then 3 times 25 is 75. But because this is 5 times 5 times 5, which is 5 times 5 times 5, this is just going to be 5. And that would be your answer. So one more. Let's do the other one that we're going to do is 27. Okay, 27. Giovanna, is it getting better or worse the way I'm explaining it?
The only part where I get confused is like, how'd you get the denominator as 5?
Got it. You mean here? This?
Yeah, like how'd you get that part? Did you like divide?
Okay, do you understand how I got this?
Yeah.
Okay. What's the cube root of 125? Or what number can I multiply by itself 3 times and get 125?
Is it 5?
Yeah, because 5 times 5 times 5 is 125.
Oh. Okay.
So let's look at 27 really quick, just so we can see one more.
Okay.
Okay. Now, I broke this down so I can see numerator and denominator, just easy for me to see. Now, watch this. I'm going to do an extra step that, I don't know, hopefully this will help you a little bit. Cube 49, if I was to break it down, is 7 times 7. Would you agree?
Mm-hmm.
Okay. But I want it to be a cube root. How many 7s do I got there?
2.
Well, to make a cube root, I need a third one, right?
Yeah.
So let's multiply it by 7 again.
Okay.
This will be, because it's 49, right? This is 7 times 7, and multiply by 7 again, that'll be my cube root. Which 49 times 7 is, so I'm going to write it here. because that'll give me my cubed root. And anyway, if you don't know, you just have to find, well, I don't know, the cubed root. That's how I find my cubed root, because 7 times 7 times 7, 49 times 7 is 343. And I don't need that because since I multiplied 3 sevens, I know the cubed root of 343. I know that 7 times 7 times 7 is going to be 343. 64 times 7 is 448.
That makes so much more sense.
Yeah.
Okay, I got one. Giovanna? No?
Ooh,
It's okay if you don't get it.
yeah, I don't really get it. I'm sorry.
It's okay. Well, Matthew, you got it. You can go. If you, no,
All right.
but you can.
You.
You can.
Bye, Sensei.
You're welcome. Giovanna, in this process, what are you confused by? Do you understand that why I multiply it by square root of 7 or no?
No.
Wait, I didn't know what you said.
No.
You're not confused by the square root of 7?
No, I am confused by the square root of 7.
Okay. What is a perfect cube? Describe it to me. How you understand what it is.
You said that you can multiply 3 like to get a perfect cube. So it's like the number times itself 3 times.
Yes. What is 49? What equals, how do I equal 49?
Is it, hold up, sorry. 7 times 7.
Yes, right? So how many times do I have to multiply 7 by itself to get a perfect cube? How many times?
3. So
Yes.
7 times 7 times
So
7.
this is 7 times 7, right?
Yeah.
That's 2 sevens. So to make it a perfect cube, what do I need?
You have to multiply it by 7 again.
Yes.
Oh, okay.
And that'll give me my perfect cube, 343.
Okay. And then
Okay, so that's what I did here. I need the cube root of 5, right? But I don't want that. I want it so it's perfect. So I need a perfect cube. So I have 1 5. How many more 5s do I have to multiply it by?
2.
So that's where I said cube root of 25. So that's 5 times 5 times 5. There's 2 5s there, and I get 125, which, by the way, just equals 5, because it's 5 times 5 times 5, right? So this is 7 times 7 times 7, which is 343. That doesn't really matter, because the cube root of that is, I multiply 7 by itself 3 times, I get 7.
Yeah.
So the thing is, you have to find the number, you multiply it by itself 3 times.
Okay.
Now let's see if we can find one more. Okay? Are you good? Are you sticking with me or?
Yeah, I'm getting it.
Okay. That was 23. Let's see if we can find one in that section. Okay, so let's do 24. It's kind of a weird one. This is not one of our homework problems. But now I have, okay, now I have the 4th root. Okay, can you read my handwriting?
Yeah, I can read it.
So I need, now I have to multiply a number by itself 4 times. So let's look at 27. 27 is 3 times 3 times 3. Do I need to explain why that is, or does that make sense?
It makes sense.
Okay, great. So how many 3s do I have in here that are in there that we can't see right now?
3.
3. How many do I need?
4.
So what should I multiply this to give us 4 3s?
Another 3?
Another root 3, right?
Yeah.
And so I should multiply this by root 3. Okay, you with me?
Yeah.
Okay. Now, Sorry, I need the 4 there. I always keep forgetting to put the 4 there. Hopefully that doesn't confuse you, because that 4 is very important. 27 times root 3 is 81. 4th root of 81. But that doesn't really matter to us, because guess what the 4th root of 81 is? Do you know what it is?
Is it 3?
Yes, it's 3, because we did it there. Because 3 times 3 times 3 times 3 is 81. We did it 4 times. Sorry, my glare's right there. And then this will just be the 4th root of 12. Because 4 times 3 is 12.
Oh, okay.
Should we do one more?
Yes, please.
Okay. All right. Here's a diarrhea one.
Oh, wait.
Let's just do this hard. This is the hardest one.
I have to charge my laptop. Just wait.
Do you need a second?
Yeah, I need to charge my laptop before it dies.
Go for it. Go for it.
Okay, I'm good now.
Good. Okay.
Yeah.
All right. Okay. Now this is crazy. I don't even have a calculator. Do you have a calculator on you?
Yeah.
Okay, great. You can do the calculations here. Okay, first step. 4th of 1296, or the 4th root of 25. Okay, are you with me so far? You see my glare.
I need to write it down. Sorry.
Okay. Just write it down and let me see if you understand what that step that I did there. Let's see if I can get rid of this glare.
Okay.
Oh, there we go. It's a little dark now. Oh, that works. Oh.
Okay.
Okay, so do you understand this step I did right here?
Yeah.
Okay, I just separate it. Now, how many do I need?
4.
How many numbers do I need that are the same?
4 of them?
I need 4, right?
Yeah.
So how many I got with 25?
5.
Yeah, how many 5s I got?
You have 5 of them, right?
For 25?
Yeah. Wait. I just brain farted. Yeah. Right?
No, you're adding. Multiplying. How many 5s do I multiply to get 25?
Oh, 5 times 5, right?
Yeah.
So
How many
2.
is that? 2. I need 2
Sorry.
more, right?
Yeah.
Okay. So what do you think I'm going to need to multiply this by to make it a perfect 4th root?
Is it by 25?
Yes, because 5 times 5. Boom. Got it?
Yeah.
Okay, now, to save our brain power here, I'm not going to multiply 25 times 25, which I believe is 425. I don't know if that's right or not. Is that right?
Let me see.
But whatever.
It says it's 625.
Oh, 625. But anyway, that doesn't matter. What do you think my denominator is going to be after everything's all simplified out?
5?
Yes. Because the 4th root of 625 is 5. Because 5 times 5 times 5 times 5 is 625.
Okay. I got that.
Okay. Now do 1296 times 25. And that'll be your answer.
1296 times 25. 7,400.
In fact, that'll probably be able to break down even more, but we'll just leave it like that. Is that cool?
Yeah.
All right.
I got
That
it.
was the hardest one.
Thank you, Sensei.
You're welcome. Do you have any other questions?
No, I don't.
All right, cool. I think that'll help you on your check your understanding.
It will.
Okay.
Thank
All
you.
right.
Bye, Sensei.
Cool. All right. See you tomorrow. Bye.
Bye.